The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone, my name is Nathan, otherwise known as Old Man Builds. What's up, Joe?
Hey, Nathan. What's up, everybody? It's Friday. Surprise!
You know what? I feel bad now because you know what? I totally forgot the intro's different.
Yeah.
So I'm going to have to play it later just for fun.
Hell yeah. Why not? You can play the extended version.
There you go. I'll play the one where I cut the clips of you and me, man. That was cool. That was fun,
that was
man.
cool. I dig that. Yeah, it just goes to show what a good time we have, man.
Yeah.
All right, so guys, what do we have today?
We got Scalar Physics, man. It's such an awesome video from Montauk, man. He went over exactly how it works, and I think it's going to help a lot of people understand it.
I think so, too. It was a great video. He did an excellent job, breaking it down and explaining it. And frankly, it's not a new resource either, So, for those who haven't seen it, I think it's going to be a real good, first watch and refresher.
Oh, yeah. Well, it kind of goes right into the woo, man, and does anti-gravity, everything we always talk about, it's in this thing. So I just thought, man, what a way to show it.
For sure.
All right, Joe, you ready? We're just going to put this on, man. Tell me when you want to stop it, and we'll just talk.
All right. Sounds good. Let's go.
That's why I'm making this video, to introduce you to scalar physics, a science that probably won't be common knowledge for another century. But you can get a glimpse of it right now by watching this video. So let's dive in. Alright, so from everyday life, you're already familiar with magnetism, electricity, and gravity. Magnetism is what makes magnets stick to your refrigerator. Electricity, in its static form, makes your clothes cling together on a dry day. And of course, gravity is what holds you to the ground and keeps planets orbiting the sun. In physics, these are known as force fields. They are invisible fields of influence that exert forces on their corresponding substances. The magnetic field, for example, exerts force on a magnetic substance like iron, and thereby attracts it. The electric field exerts force on something that is or can be electrically charged, like an electron or a proton. And the gravitational field exerts force on matter according to its mass. Now, on the surface, it seems that these three fields are totally different and separate from each other. But what if they're not really separate? We've already known since the 1800s that electric and magnetic fields are really two sides of the same coin called electromagnetism. But how gravity ties into that has eluded science to this very day. So what if the magnetic, electric, and gravitational fields are just different expressions of a common underlying field? What if they arise from different kinds of distortions in that field? You see, that's what scalar physics is about. It's about understanding this single fundamental field and how exactly it gives rise to the three force fields. Because with that understanding, you can work out how to manipulate them. For instance, to distort gravity, you might use nonlinear electric fields or rotating magnetic fields. And because gravity involves a distortion of space and time, by controlling gravity, you can control space and time. That's where the really exotic applications come in, like time travel and opening portals to other dimensions. Alright, so that's a general overview of what scalar physics is. Now let's go a bit deeper into the details of how that all works. To do that, I'm going to explain some common terms and concepts that are used in mainstream physics, because scalar physics is just the logical extension of that, so it's important to understand these terms. Alright, so the reason that we call it scalar physics is because the fundamental field that gives rise to the three force fields is technically a type of scalar field. Now, there's nothing exotic about the term scalar, okay? It's just math speak, meaning a single number or a single value. The number 10 is a scalar. Distance is a scalar. Weight is a scalar. Temperature is a scalar. Altitude is a scalar. So a scalar is just a single number describing some particular measured value. A scalar field, on the other hand, is one where each point in that field has one number associated with it, usually to denote the strength of the field at that point. For example, the distribution of temperature in a room could be thought of as a scalar field, because at each location in that room, at any given moment, there's one temperature associated with that one spot. Same with air pressure, or population density, or altitude. These are all scalars, which, when mapped over space and time, makes up a scalar field. What distinguishes one scalar field from another, then, comes down to what exactly is being measured. In scalar physics, the scalar field is measured in units of magnetic flux, or quantum phase, or action, depending on how you want to interpret it. But that's getting ahead of ourselves, so let's continue. Besides scalar, another important and related term is vector. A vector is like a scalar, except instead of being just a single number indicating field strength, it has additional numbers describing the direction that the field is pointing towards. So a vector field is one where each point in the field has both a field strength and a direction associated with it. A common example would be a weather map showing wind speed. One spot shows 10 miles per hour north-northeast. Another spot shows 5 miles per hour southeast. These measurements are vectors, and the entire map makes up a vector field for wind.
Hey, here's a
Now,
good
the
place to
electric,
pause, I think.
magnetic, and gravitational force fields are vector
Yeah, so whenever you're visualizing these fields, just generally speaking, or flows, I shouldn't even say fields. I don't want to trigger anybody with that, right? When you're imagining the flow patterns that any given uh, of any given interaction of a scalar, okay, the vector is the critical thing, and in context of some of the things that we deal with, a lot of the vector has to do with the um, with the directional propagation from the source of emission, right? So if you trace your vector back, it should lead to the source of emission, is what it kind of boils down to, and that's one thing that when you're looking at any given electrical circuit that you're trying to get a result out of, that's what you should be considering in your head: is where is it coming from, where is it going, what's it doing, what's it bumping into, and how does that interaction affect both ends of the interaction.
Okay.
And that's what brings that scalar visual into the vector motion for purposes of trying to understand these things.
Gotcha. I wanted to answer a question real quick.
Sure.
You won't find any magnetism in longitudinal. He hates magnetism. He's 100% right.
Mhm.
It's a radiant field, and if you put pressure on it too much, it becomes a radioactive field almost. It's a radiation field. So there's a difference in it, and they haven't gotten to that portion of the video yet, but there is a distinction. In a radiant field, there is no magnetism. It defeats Lenz's law all day long. So he's absolutely 100% right. So we'll get into that a little more. It explains it better in the video later. It's hard because he's going to try to translate physics terms into what we should know about scalar. So
Yeah. Right. So, I mean, the trick of this all, with no spoilers, is it comes down to modulating and manipulating the flow vectors. So, different types of magnetism or electromagnetism have different flow signatures, more or less, as to the pattern of the disruption of the ether that they create, and in turn manifest different electromagnetic effects, being electrical, magnetism, and gravitational, which are all interconnected together, and then all directly connected to time as well. So
Yeah,
it's
we're gonna get into the time aspect.
we're
of it.
getting there.
Yeah, Michael's way ahead of us. So we'll play a little more, man, and we'll get into it, because
Yeah, let's do it.
I think some of the important stuff is just the general physics, so that people understand where it is and where to find it. Then we
Absolutely.
change it, because my numbers are not these numbers at all when I write them. So
The
all right.
visuals are great
Two.
too. So
They exert a certain magnitude of force in a certain direction upon a given particle in that field. Now, where it gets interesting is that even mainstream physics recognizes that force fields are not primary. It teaches that the three force fields that we know are actually the result of distortions in more fundamental fields called potentials. There are three main potential fields that are used in physics. One, the electric scalar potential, more commonly known as voltage. Two, the magnetic vector potential, which is like a kind of electromagnetic momentum flow. And three, the gravitational scalar potential, which in Einstein's theory of relativity determines the rate of time. So these are the three potential fields that give rise to the electric, magnetic, and gravitational force fields that we know. Let's take a closer look at how that happens. Magnetism comes from circulation in the magnetic vector potential. So when the magnetic vector potential circulates like a vortex or a helix, you get a magnetic line of force along the axis of that circulation. It's kind of analogous to wind in a tornado swirling around the tornado's vertical axis. We call that circulation curl, and in math and physics we say that the magnetic field equals the curl of the magnetic vector potential. Now, the electric field, on the other hand, comes from a gradient in the underlying electric scalar potential. Gradient simply means that the value of the electric scalar potential varies over some distance, and the electric force field just points along that gradient. And similarly, the gravitational force field arises from a gradient in the underlying gravitational potential. On Earth, the gravitational potential varies linearly with the height above ground, or to be more accurate, the radial distance from the center of the planet. So we experience a vertical gradient in the gravitational potential, each height having a slightly different potential, and that produces the gravitational force that we feel. Alright, so potentials are more fundamental than force fields, and give rise to them when they are distorted in certain ways, like having curls or gradients in them. But what if these three potentials are not fundamental either? What if they're expressions of an even deeper underlying field? Well, if you follow the math, you'll find that there is a deeper field, but it has no official name. It shows up in textbook discussions on so-called gauge transformations, where it's generically referred to as some scalar function, but sadly, it's glossed over without further discussion. So let's work with it and give this deeper field a proper name. Let's call it the scalar superpotential. Scalar because it has one numerical value for each point in that field, a value measured in Webers, and superpotential because it's even more primary than the electric, magnetic, and gravitational potentials. We can denote the superpotential by the Greek symbol chi, which looks like a letter X. Alright, so how do the three potentials relate to this one superpotential?
Okay. Before we go any further, let me just tell you, gravity is not a cause, it's an effect. So when he says those three potentials, it's wrong. And it goes right to physics and where they are and how they think about it, because they think gravity is a cause, and it's not. It's the effect of longitudinal waves. It's the effect of the radiant field. It is literally the center of your Tesla coil. It's the scalar field that we're talking about here, the longitudinal wave. So it's a mistake that the way they put it, though he explains it in regular physics, which I understand, but it won't come out that way when you know which one is which, right? Because some of them cause things, some of them are the effect of things, and gravity is an effect.
Right. Gravity is a byproduct of toroidal flow,
Mm-hmm.
more or less. Anytime you have a toroidal movement with, an inner compression, there's going to be that null zone. And it's within that null zone that it's not really null. It's just changing the flow pattern from one thing to another, and just changing the vector.
Yeah.
Like,
So I wanted to throw that out there because I think this is what ruins people when they look at it and they can't understand gravity because they don't see it the right way. So hopefully that helps, but it'll probably confuse most physicists and probably piss them off. But all right, let's go ahead and play some more.
If we can figure that out, we'll have an idea of how electricity, magnetism, and gravity all arise from that single unified field. Let's start with the electric scalar and magnetic vector potentials. 1. When the scalar superpotential changes over time, you get the electric scalar potential. And 2. When the scalar superpotential changes over space, you get the magnetic vector potential. Pretty simple, right? This means that the electric force field, which remember is the gradient of the electric scalar potential, arises when the superpotential varies over both time and space. And the magnetic force field arises when the superpotential varies over space in such a way that this variation curls to form a kind of helix or circulation. This is all textbook physics so far, and you can do the math and show that it's legit. What about gravity, though? See, that's where scalar physics goes one step beyond the mainstream physics. It does so by proposing a very special postulate, the key to it all, which is that the gravitational potential is a product of the other two potentials. The postulate says that the gravitational potential arises when there is a divergence in the magnetic vector potential, and when the electric scalar potential changes with time in a curl-free way. Let's break those down. So normally, as we discussed, the magnetic vector potential curls into a magnetic force field. But when it doesn't curl, and instead diverges or converges, that's what scalar physics says produces a gravitational potential.
Okay, right there, that's the center of your testicle. No question, right there. He's telling you flat out that's where you find it. There is your gravitational wave. Right there, your longitudinal is the center of your testicle. So just want to point that out so people understand that that's exactly what they're trying to tell you.
Divergence of the magnetic vector potential is key. Divergence is a math term meaning that there is some kind of expansion or compression in the field. In other words, the field vectors point away from or towards a common center. And that's the opposite of curl, which involves the field circulating around something rather than converging or diverging from it. As for the electric scalar potential, that can also create a gravitational potential under certain conditions. Normally, as explained, the electric scalar potential has a gradient that forms an electric force field. And if this electric field changes over time, then according to Maxwell's famous equations, you get a curling magnetic vector potential that produces a magnetic field. The electric and magnetic fields in that case fluctuate together and propagate as an electromagnetic wave, whether as light or microwaves or radio waves or X-rays. That's what normally happens. But what if the curl of the magnetic vector potential is suppressed or canceled out? What if you set things up so that the magnetic vector potential does not produce a magnetic field? A simple example of that for anyone curious would be a spherical capacitor with an oscillating electric field. Then what you get instead is a changing gravitational potential. So instead of a...
Okay. Sorry, I know I paused it a lot, but it's the same thing when you're spinning a sphere like I'm trying to do in my device I'm working on. We're trying to create a gravitational potential in there in a gravity well by spinning the actual gravity field, the one he's talking about, the center of the Tesla coil. This is exactly what we're doing. That is the precise thing to do. You saw how it built out around the Earth. You saw the different fields. You could see it behind us right there. The different fields building out. That's scalar. That's temperature. That's frequency. It's all of it in one. And it builds out. So if you look straight down on the image, it looks like a Tesla coil and comes out like rings, right? But if you see it in a spherical sense, then it comes out as a sphere, right? So each one is a rounding sphere around it. So just so we all understand that, that's exactly where your gravity's made. It's the impingement of field is what it is. You're forcing it to go in so that it breaks out. It's like when I say demon core, as soon as you close it, right, boom, it's compressed. The compression then burst out, and it burst out in different levels. So wherever you stand, it's going to have a different level on each one of them. That's exactly what we're doing here. It's 100% right. All right, ready?
Transverse electromagnetic wave, you would get what's called a longitudinal electrogravitational wave. Transverse means that the field wiggles side to side as it travels, which is what electromagnetism normally does. And longitudinal means that it compresses and expands in the direction of travel, which is what these artificial gravity waves do. So that's just one application of scalar physics, using a changing electric field to produce a gravitational wave. For posterity, let's put everything together on one screen and show how the magnetic, electric, and gravitational force fields all come from a single underlying scalar superpotential. 1. The magnetic field equals the helical curling of the gradient of the scalar superpotential. 2. The electric field equals a gradient of a time-varying scalar superpotential. 3a, the gravitational field equals a gradient in the divergence of the gradient of the scalar superpotential. And 3b, the gravitational field equals a gradient in a time-varying scalar superpotential that varies over time. Now, is this all just theory, or is it supported by real-world data? Well, if you dig into the subject of suppressed inventions and anomalous phenomena, and if you ask yourself whether these things might involve diverging vector potentials or time-varying curl-free electric potentials, you'll find that not only are they present, but they're the very key to the operation of these technologies or phenomena. I'm talking about things like ball lightning and exotic vacuum objects, the Biefeld-Brown effect, Tesla's wireless energy systems, longitudinal forces in railguns, the exploding wire phenomenon, Stefan Marinov's magnetic ionization device, low-energy nuclear reactions, plasma-based free energy systems, and that just scratches the surface. Alright, so with that one postulate that the magnetic vector potential and the electric scalar potential can each produce a gravitational potential under the right conditions, you open the door to Star Trek level technology. And because this is all based on real math and not just fanciful imagination, you can work with it, you can simulate it, and you can build with it. So the natural thing to ask is, why don't we then have access to that technology right now? Why don't we have flying cars and time travel? Well, it's because scalar physics has been suppressed for almost 150 years. Physics took a very wrong turn in the late 1800s,
Right there.
and vested interests have ensured that it never got back on track. There's a very tight system of groupthink, censorship, and suppression in academia that keeps anything too unorthodox from getting funding for research or approval for a publication. The divergence of the magnetic vector potential does indeed show up in physics textbooks, but can you guess what people in academia have done with it? In their own words, they have murdered it. When it appears in their equations, they act befuddled and irked because it complicates things. They claim that it doesn't have any physical significance because they can't measure it and therefore don't know what it means. They say, since it's not physically real, we can make it whatever we want it to be. So why not set it to 0? Or set it to be the opposite of whatever the electric scalar potential contributes?
Okay, we're going to stop right there. That is absolutely the worst thing they could have done. Everything has a value if it has a field. It's pure ignorance at that point.
Well, but it was by design. It was by design, though. Yeah.
Yeah, that was horrifying.
befuddled anytime it comes into their equations. Yeah. What an inconvenient, truth, huh?
Well, of course, it's inconvenient because to them it's an anomaly when you build something,
Mm,
and it's the exact anomaly that you need to get to anti-gravity. So,
Yeah.
now I will say this: you did a very good job on the video because it's tough to take mainstream physics and then move on to the physics you need for anti-gravity because it gets confusing because a lot of people that wrote the equations aren't seeing all of the things built out the way they're supposed to.
Yeah, no, he did an excellent job, and I think that the visuals that he used also to help explain the concepts are just as fundamentally important for people to get their heads around the stuff as the equations are. The equations that are there to support the concept, but the visualization of the concept is going to really take people's understanding to that next level, to the point where they could maybe start to incorporate these ideas into their own designs.
Yes. So Toymaker's 100% right. It's not its own field, gravity. It's not.
Nope.
It's they should replace gravity with radiant, and then they would be able to get gravity out of all of it together. It's the effect, not the cause. So, yeah.
Right.
And
And that was the point of, we go way back to when I started talking about this stuff with you, the second time I was on. It just goes right back to, there's pure potential, and every single way that you mess with the still of that potential is exactly what manifests after that. And it all becomes a cumulative circumstance, where you start getting more complex interactions that have byproduct effects that we deem to be observable, measurable, usable, whatever have you. Like Nathan's saying, like the video said, gravitation is pretty much all the way at the bottom of that. It's sort of the sum of all the effects, and it's the byproduct of it.
Mm-hmm. So the equations have to just change a little bit. That's all we're saying.
Mm-hmm.
I mean, you just got to know which field's which and why they're there, and then change the equation, and we have anti-gravity. But this is one of the hidden secrets, right? So if you were just dealing in equations from Maxwell, then you're in trouble. But if you wanted to finish Lorenz's work and do the ether, then you have to add this, and then boom, his work is perfect after that. It would have fell right in place. He would have known it. We would have already had this done.
Yeah. And it's just important to realize that the control over the attributes of gravitation are very similar and directly intertwined with the control of both electrical and electromagnetic forces. So, it all has to do with geometry and modulation. So if you could create the correct geometries and then modulate to be able to get the flow of the the magnetic field to do what you want it to do, and then your gradient of your electrical inputs are correct, then at the end of the day, what you should be doing is influencing the gravitational effect through those two attributes alone.
Yeah. I mean, look, gravity's just kind of like a saturated field, man. That's all it is. And it has to be that way because centrifugal force would throw us right off this earth. That's how fast the earth rotates. Like in that UFO machine you get at the fair, and it goes around in circles, and you get sucked up against the wall. Well, we'd be flying off the earth like that. You know what I mean? No parachute. Yeah. We're just right out of here.
But you got to remember where the ride operator on that ride sits.
Oh, he's in the center, but
he sits in the center where he's basically unaffected by any of that.
Oh yeah, but that wouldn't help us here.
Right?
Yeah, doesn't help us standing on the earth because we're not in the center. That's for sure.
No, that's for sure.
So you gotta have a field to hold us in.
That is interesting to think about, though, I have to say.
Yeah, is there gravity in the center? No.
There can't be. It becomes a scalar vector, because if you have everything coming toward the surface of the Earth, your vector is inward at your at your center point. That means that all the vectors are just pointed inward, and therefore there's nothing to go, like no matter, you can't fall up, down, or left or right.
Yeah, I like the way he described what scalar is, and I'll go a little more into it. It's temperature differential when you're standing on the Earth, on the ground part where we are, versus the top of a mountain. So you're sitting on the Earth at top, right? You go to the top of the mountain, it's cold. Well, we know the higher frequencies are up high, lower frequencies are down below. It all matches the way it works.
Mhm.
And then there's a gradient between each single level of it that gets you there. So there's a different frequency between each. So how does that tie into like a Tesla coil? It's because it's building the ring in the exact same way. The Earth is just 360 degrees, so the geometry is different than a Tesla coil. That's why the picture behind us is so important. It's showing you the same thing. That's what scalar is, the temperature differential with the frequency differential between each one, where the amperage field is towards the Earth and the voltage field's up high by the mountains. That's why in the sky you get so much energy that's just up there. You could pull it out with no problem, and it's like static electricity until it hits a storm cloud. Then it converges and then shoots lightning down at you. So it's not hard to figure out, but that's what's going on.
Yeah, and this goes right back into well, there's two examples I don't want to give that are directly related. Goes right back into the spacing of different electric potentials, right? Because we know that different effects manifest depending on the distance of two conductors apart from each other, right? So that's a direct result of the gradient that takes place. So the higher the density of electrical charge in the gradient that you bring it to, the different effect that you're going to ultimately see in that scenario. On the other hand, if you look at like two magnets and you just imagine like two flat neodymium magnets, right? The north and south poles, which are the more or less scalar vectors out the top of them, right, are set. Okay, those don't have a gradient. They just are what they are. Okay, however, the magnetism effect does have a slight gradient, just much less so than electric, right? So whenever you draw a magnet close to something magnetic, right, you could start to feel it attract before it ultimately catches, right? But once it catches, it's usually a pretty quick draw in to it, so you could feel that attraction slightly and then bang, right? But electric is just way more gradient than that, and that's all to do with the flow pattern, right?
Yeah. Well, okay, so I got a question. The vortexes are not scalar.
The vortex isn't.
No. I just want to make sure yeah, okay. I just want to clear that up. I thought I heard that.
But what is the directional of the pole that goes up the center.
Mm-hmm. Okay.
So if you have a flow like this in a magnetic field, right? That's this and that is not the north or south pole. It's going to be this or that. So if it's turning this way, my finger is pointing north and south. See?
Oh, you're doing the right hand rule thing?
There you go.
Okay.
So, that's what I'm saying. And in that case, my finger would actually represent a scalar vector that's just up and down on the pole. And it all suffers from it, because if you think about a round magnet being perfect for this example, in the dead center of the magnet, is it north or south? Does the dead center of a magnet have the same magnetic properties as all that's around it? I don't think so.
No, it's different. There's a flow inside. If it's open,
test that with a pin. take a steel pin and just drag it across a magnet, you'll see that it tracks less in the dead center than it does anywhere else.
Yeah. I think a lot of this stuff gets confused because of how we turn things on. And everybody's under this assumption that, we need these, I don't know. You basically turn the damn Tesla coil on with a longitudinal wave. That's what you're doing. That's it. You're just pulsing it. It's as simple as that. You're just pulsing it. And it really doesn't matter how you pulse it, it turns it on. Okay? As long as there's some form of magnetic potential there, it turns on. So pulse it with anything you want. Have a great day with it. And it shows in all the different oscillators we use to do it. All we're doing is pulsing a field. As we pulse the field, it basically creates a wave that goes like this, which is the ring, which shoots it out. And the ring itself told you that it was scalar because of how it moves like this. In each way, it built out a different field in each single layer. And you got to remember that. So when I tell you it's harmonics in that, every layer, okay, the closest to it is the strongest field. Then it gets to a weaker field, and a weaker field, and a weaker field. That's the way it works, guys. It's just the same as a Tesla coil. It just builds out the same way. The harder thing to see is when you put it in 360 degrees, because we always look at things the wrong way. We always look at it in 2D. When you put it in 360 degrees, you're just looking at the volume of a sphere, is the energy potential in each gradient level. That's it. That's it. That's why we're doing the experiments like this, is because we're going to prove that out. And the amount of energy in between is your gravity. That's it. It's just how much the fields interact. It's no secret that it's a field that's such a low static that it's like 0.00 of an amp, and the rest is electricity. And then as you move in this world and you rub against things, you create heat. Heat creates an amp, you get a static field, and you start zapping people. That's not hard to figure out. What holds that in? A radiant field. Then what happens? When it gets too tight, it builds radiation. We have our Van Allen belt. Dude, this stuff isn't hard to figure out. It's all right in front of us. It's getting them to realize which field is which. So that's kind of the...
I mean, yeah, which field is which, but also just acknowledging the pure potential field, the ether, like that's really the critical element, because if you're going to deny a common prerequisite to these types of energy, then how are you ever going to A, tie them together, B, how are you, it just, if you think that they're fundamental, then that's where it goes wrong. You have to realize what they're manifest of in order to be able to go that one step further back to be able to realize how it could be manipulated.
Yeah. And by the way, Sal Paez told you, when you take those two fields and you force them against each other, you get plasma. Just look up in the sky. We don't stand on this earth without the plasma in the sky. So just understand it for what it is. It's those two fields pushing against each other, and they have to have different temperatures because that's the way scalar works. And the more further apart the temperatures, the stronger the field's going to get. It's that simple. There's no more to it than that. He told you that you need the longitudinal wave. That's gravity. That's where you're going to find your gravitational wave. That's how you're going to beat it. There's your anti-gravity right in there. It's what's going to force gravity. And without that, you don't have gravity.
And just for full clarity, in temperature differential, like that's the same thing as saying like radiation density, more or less.
Yes.
Like, right. So you really have to bring it back to not only the heat being the effect of the radiation density, the type of radiation. What is radiation? Radiation is the disturbance of the ether at a certain rate over time, right? And that's on its own vector trajectory of interaction. It's just kind of how you have to think about it.
Well, let's go to the core of the earth then. We always want to talk about the ether, right? So let me bring this analogy in so we all understand it. The Demon Core, when they did the nuclear experiments in World War II, they had this core left over and they were working with it. And as long as you kept a screwdriver in it and didn't let it close all the way, you're okay. The second you let it close, you confine the fields, which means that you force them together really hard, right? What happens when you force them together really hard? It breaks out and creates a field that goes this way. So when we talk about the 0 point in the Earth, that's exactly what's going on. We don't have fields that push out without them forcing in first. Therefore, we're going to have a very confined field in the center of our Earth, which is like, you can call it a sun if you want. You can call it a plasmoid. Whatever you do, it's a very, very high voltage potential in the center of our Earth. That's everything. It is no magma right there. It is pure energy that's being forced in, and it's just making it force itself back out.
Well, I mean, it doesn't matter what it is or isn't. That's what it is. Like, you know, as far as the material makeup of it is concerned, is totally secondary to the density levels and what they're doing in that circumstance of extreme pressure and you know, in an extreme condensed state like that. That, you know, so what it is, like if it's a ball of iron or it's just other mineral composition, you know, who knows what it is, but you know, it's definitely what you're saying as far as the energy is concerned.
Well, we saw with John Bigman the hydrogen, right? And how it breaks out.
Mm-hmm.
Well, just think of the hydrogen with its electron, just like the Earth and the moon. There's really not much difference there. That's exactly how it's fundamentally acting. Mm-hmm. We're literally just creating, you know, atom of hydrogen is what the Earth is. So then it breaks down to different materials just like hydrogen does, and you can transmutate it and combine it and create different elements from it. But the base thing is a hydrogen atom, and it literally has the moon running around it. And that's all we're doing. And it's forcing the fields to come out further. So I always say Mars, what does it need? It needs a moon. Why? Because you can't force the energy in hard enough in Mars right now without it to get it to pop back out.
Right. So that whole concept basically, and correct me if I'm wrong, but doesn't that just make like the Earth like a huge natural dynamo?
Yeah.
Pretty much.
Yeah.
Yeah, that's what it is.
Pretty much. I mean,
mm-hmm.
I mean, we live in pure energy, man. I mean, let's not fool ourselves. We have a radiation field that is the plasma field around our Earth, and it gets pushed on by the fields of the sun and stuff like that, and then it forces our field back on us. We always say it's the sun's rays getting us, right? No. The sun's rays push against our field pushes back on us. It's literally our Earth that saves us and hurts us at the same time. So.
Well, right. We're just lucky to have that interaction of equilibrium with the sun that allows us to kind of coexist with it. You know, obviously there's other planets like right close to us that aren't quite that fortunate and have had their atmosphere stripped away just by being, you know, out of equilibrium, but didn't have enough energy themselves to match up to the diffuse gradient output of the sun, more or less.
Yeah, if you take the picture behind us and say it was the sun, right? Each one of those lines represents where one of the planets is. And the planet stays right where it is based on the frequency of it. It literally will stay right there in that potential zone because that's where it gets the energy. As it gets the energy, it sticks in that zone. When you get something that's way out of it that flings, then you got a different story going on. There's several different frequencies in there that's really changing that whole planet. So it's the reason everything builds out in rings. You know what I mean? Everything out there is scalar. It's instantly there. It's always there. We can't see it. It's basically a clear plasma that's sitting out in between each planet. And it'll go between the high amount when you get towards the planet and then a low amount when you get away from it. And the reason that we say we have a magnetic field is because when you create radiation, there's a small magnetic signature, but it has no magnetism. Therefore, it beats Lenz's law because you can't get your magnet to cause and affect it. It won't happen. It doesn't interact. It just doesn't see it.
Yeah.
So,
I mean, I'm on board with John. You know, he said that we are radiant matter. You know, we suck in the sun's energy and radiate it back. And
yeah.
that's what we are and everything that's around us. So I'm on board with him with that. You know,
Hold on. How did we get to the Earth isn't rotating? I don't agree with that at all. We're definitely rotating.
oh, yeah. Too much evidence to sit there and play with that one.
What's the difference between ether and, let's see what I say, ether and scalar? Well, the ether is both fields. It's both fields. It's the static potential, and it's also the radiant field that goes on around us that create the ether, right? You have to have both. If you just have one, you don't have it.
Right. The ether is the prerequisite to any other manifestation of energy in reality. So it's that pure potential, that super potential that allows for scalar vectoring to occur in the first place, because that scalar vectoring is just a specific type of disturbance in the ether that is then cause of effect.
Well, okay. So let's go back to this.
And I'm sorry, but ether, in terms of the video we just watched, ether itself is a scalar field, okay, in the sense that there's measurable disruptions over time within it that we observe as electromagnetism and gravity, right? And you know, there's also vectoring in it as well. But the thing is that just because it's observable in the field, it's important to realize that the field does not exist if not for those disruptions of scalar within it. It's more primary than that, like you said. I think that was a good way to put it.
Yeah. Well, there's definitely 0 point energy in the center of our Earth. I mean, I'm sorry for everybody that tells you anything different. If it didn't have it, we wouldn't be here. It's just literally the way it works. If there wasn't a huge amount of energy in our Earth, we wouldn't be here. And you cannot create magma flows inside the Earth without energy, tons of it. And I mean, a lot of it. How are you getting it there? Because it's not traveling through from the sun to us, not in the way that everybody thinks it is in these waves and these bursts and the pressure it's putting on our planet. No, it's not. It's creating resonance in there, which creates the energy itself. And then because it's oscillating, it's just putting it in the double vortex, which we see all the time from our Earth.
All right, so I'm going to be the person that ruins a lot of people's days right now.
Okay, go right ahead.
All electricity, all energy that you use is 0 point energy. It all is. All of it. Okay? The method of electrical generation, okay, is pretty much the same, and it has to do with magnets rotating in around conductors, causing a disturbance of the 0 point field that can then be extracted off as electrical energy. That's how every ounce of energy that you consume on a daily basis is. The question has nothing to do with 0 point energy. All right. So this is why I'm going to ruin everybody's day, because you want 0 point energy, you have it. Plug some shit into your wall. You're using it right now. That's it. Like, what it comes down to is we use mechanical means which cost energy to then create energy. So it comes at a high cost. And then we utilize it in the most inefficient ways possible because we're ignoring the source of what it comes from in the first place. The entire idea here is to get rid of the mechanical intervention and the high energy cost needs in order to create the same types of electromagnetic fluctuation that occurs that creates electricity that can then be captured, stored, used in a more high efficient manner. The 0 point energy, for that reason, okay, is very real, and it's also the biggest misnomer and fluke that's out there. You have to realize really what it is in the first place, and then what you're trying to do it. All the devices that everybody makes, this is all a matter of being able to get the same result in a different way, okay, and then being able to utilize it in a high efficiency manner that allows for the continuation of the creation process of the electricity, okay, without mechanical intervention. So right now, all we do is we trade hydropower, nuclear power, fossil fuel power. We trade all of these different types of natural or unnatural energies to mechanical motion to create it. All we're trying to do is eliminate that element of it, so it doesn't have an associated cost, and that it runs off of what it's able to create. Which, if you're not getting what I'm putting down, it's possible. Like, that's it.
Oh yeah. Well, we can't create or destroy energy. We can only draw in the vortex. That's all we're doing. We're creating a device that draws in the vortex. So we're pulling in the energy from the surrounding area. As soon as you understand that, over unity becomes very easy. So does 0 point. If you understand that you're just pulling in the energy around it, that you didn't create it, that the earth already did it and it's already here, all you're doing is finding a better way to pull it in, then it becomes easy to build. Because now all you have to do is build layers of it. And it has to be just like in Scalar. Everyone has a different frequency. Everyone has a very different temperature differential. And you're building layer after layer until you get to enough layers that the multiplication factor drives it through the roof. That's it. That's as simple as it
What
gets.
I think is important for people to understand too, and I think our group, the people that are here all the time, they know this, but when we're saying pulling in, it's just a good way to say it for to keep it simple. But it's not really pulling in anything so much, okay? Because pulling in sounds like a carburetor pulling in, gas and vaporizing it for use or something. That's what that kind of sounds like to me, at least. What it means is that there's always this potential that's around us, and it's just simply a matter of stirring this potential in a certain way to then get it to carry into a potential state to a electromagnetic state. Once you accomplish that transition from potential to electromagnetic state, now you can harness it. And so it's not, when you actually do this, you're actually not drawing in or taking away anything. So it's not like this supply of something. It's an endless supply of something. It's just a matter of continuing that aggravation of the area in the proper way that allows you to manifest the correct result.
Yeah, you're basically building an energy well.
That's exactly what you're doing. Yeah, it's about jostling. It's about jostling the energy up, and then, like he was saying, you want to create that into that jostling in the presence of matter will become react with conductors, which is the point. Once you react that potential with a conductor present, then the conductor can start to carry the charge, and it's that charge that's omnipresent along the conductor that is able to be utilized as electric, and then from there be utilized as an electromagnetic force.
Yeah, it's like we always talk with Gerald about, you put the cup in, and the cup is always full, always,
always full.
Because it's not your primary mover that's giving you the energy. It's not perpetual motion. It's not going back on itself. It's not doing any of those things. It is basically you're paying for the foundation of this thing, the primary mover. You're paying for it. And it runs, and then what you're getting, the energy that goes into it and builds up, it doesn't have a loss. So it stays. It's a fountain. It continues to keep going.
Yeah. Now, one thing that does directly coincide with it, and that becomes very interesting now that we've taken the time to describe it this different way, right?
Mhm.
Is cavitation, because cavitation is is a is a directly related phenomena that takes it to that next layer of it. Because what cavitation is taking this all the potential interactions and breaking that locality into a gap and then just having your pure potential there. Now the crazy thing about that is you can shove whatever the fuck you want in there and it'll try to collapse on it and just be in an omni state of collapsing and expansion, as long as you can sustain those high energy levels inside of it, because it has nowhere to go. That cavitation is the critical circumstance that sort of has to exist in creating that the charge differential great enough to sustain it, and that's what breaks locality. And that's what we've been talking about a long time, is this breaking of locality, because that's the critical aspect to being able to utilize your scalar vector in a way that we would consider to be antigravitic.
Mhm. So, in simple terms, it has to oscillate back and forth. It can't just be one field on at all times. It doesn't work that way.
Mhm.
You need that back and forth, and the oscillation in order to make it work. One's on, one's off. One's on, one's off. That's the way it works. So that it can allow some of the energy in very small amounts on the Planck scale to move between each one of them. And then you get the leaky capacitor at the top, which rounds itself back down to the bottom. Now, when you start creating that, you start creating time dilation.
Mhm.
You have to have a leaky capacitor to get time dilation. It's part of the club you got to be in. So as soon as you could do that, man, you could do anything you want. And then, we haven't even talked about amplifiers in there. The cavitation's an amplifier in itself, but a pulse to that whole thing is a monster amplifier. We use piezo discs to pulse stuff like this in the capacitor in order to get it to jump. And it's because we're just pushing fields upon it. We're forcing in more energy at one time than it likes to have. And it's forcing, energy in a direction. So if we pulse the top, energy flows down, pushes us up. You know what I mean? It's as simple as that.
Right. And, that's, if you want to visualize that same phenomena in a mechanical sense, and I've said it a million times, but you think back to the bubbler on the thunderstorm generator, because that's using the natural rhythm and resonance of the combustion engine that's in states of compression and expansion, that as the micro bubbles move up through that bubbler, they're in a constant state of being squeezed together and expanding, and that builds the energy from the ether. Is that oscillation? It's that it's the separacy, because the way that the bubbler works is smart, because that breaks locality with the bubble, because there's a phase difference between the gas and the liquid. So they did it in a literal sense, whereas your phase difference in atmosphere would be more electromagnetic in nature, as opposed to whether it's a solid, liquid, or gas.
So the energy that's produced, or that comes into it, however you want to say it, by splitting everything apart or putting it together, is so much bigger than the energy of just the hydrogen by itself. Just so people understand this. That's what Stan Myers is doing. He's over there, and as he separates something, it creates a massive amount of energy, or it draws in a massive amount of energy, right? Because you're pulling things apart that are forced together. Then when you force them together, boom, they create energy again, or push it out, however you want to say it. That right there is the effect they're looking for. That's where you get your energy. And as one breaks, multiple breaks, you get a Townsend effect. It just, boom, shoots off to everything in every direction and blows it out. You're not getting it from the gas. That's a misnomer. That's a misunderstanding of his technology. It's
Absolutely.
the separation effect that gives you the energy.
Mm-hmm. Exactly, because it all comes down to differentials, and it always has, and it always will. So what's the enemy of a differential? is a gradient, right? So when you look back to the video that we watched earlier, these electrical gradients that exist, they start off at a higher density, high charge state and dissipate as they move out. If you press that in and you just have this higher density space, and because it, by virtue of whatever it's being pressed in by, and call it a magnetic field at that point, right? On the other side of that is going to be something vastly different than on the inside of it, and that's the separation, where the gradient effect starts to still build out, because that's naturally what it wants to do, but it's less so, and it's more, and those fields are still compressed as well. So it goes from being like a smooth gradient to different layered compression zones. And that's sort of what you're describing. It's the difference between, taking all the paints in a rainbow and blending them together seamlessly versus taking all the colors in the rainbow and just drawing a line of each color, and that's it. It's the line thing that you want, because those are the compressed fields.
Yeah. So when they do the spheres in that thing, they're very specific about what the distance has to be. And it's because one's ringing the next one. We always talk about the Tesla coil ring, and it goes, smaller, bigger, bigger, bigger. Just think of it that way in the sphere that builds out. It goes bigger, bigger, right? It's the same thing, and it has to ring along that same level. If it doesn't ring, you don't hit the harmonic. If you don't hit the harmonic, it fails. Yep. And it's so hard to put that out when you do the calculations and stuff in order to build this stuff. It's a little tougher than most people would think, because they just go, oh man, I got a little ball at work and I get another little ball. It doesn't work that way. It's very specific on the actual sizes of everything.
Right. It's the same but different in that octave, because the fact is, it's just got to be in tune. Constructively in tune.
Yeah, that's why you use the ring. It's like radio frequency in a Tesla coil. You turn the dial till it hits a high point, then you turn the dial again till it hits another high point, and then you'll find another high point. That's following your Tesla coil ring as it goes, right? So if you build out fields based on that, man, you're perfect. You understand exactly what's going on. I have Tesla coils I have set up right here. I did an experiment today. I can turn on different parts of the ring on that Tesla coil. Just different parts of it, different energy levels that I put out, like frequencies, will turn on different parts of it. So I can turn it on the ring halfway through, 3/4 of the way through, or all the way to the maximum amount. Every single one of them will turn it on. And it all just depends on my primary driving coil. So, by the way, that's so much harder than you think it is to put those things in resonance, to get them to light up without anything attached to them. It's like a circus, man. You're flipping on and off capacitors, and the resonance frequency of the main coil is not the same resonance frequency of all the secondary coils. So it may be a crappy resonance frequency for the main starter coil, but it's a perfect resonance frequency for the rest of them. It's just matching things up is a little harder. So I literally pull wires out of the top of the Tesla coil and cut them off and throw them away, so that I can get the exact same frequency, because it's literally point something. It's like 2.5 is the most you can go on both sides. That's in kilohertz. And past that, it will not resonate properly. It will not even barely turn on, if at all. And then if it's anything outside of that zone by at least 1.2 more, it won't work at all. There's zero frequency transfer. Zero energy transfer at all. It's like two ships in the night. They just don't even see each other. It's like AM radio stations. They just don't see each other.
Yeah.
So that's kind of cool, man, when you start getting into this kind of physics, because then it really explains a lot about what we're doing and why fields build out. And it's the first time I found that Tesla coil field, oh my God. What a change, right? It was like, why is this person use this? Why is Alexi doing this? And then I started working with it, and I go, now I get it. I get it.
Right. It makes you see things a totally different way. and then floods you with 1,000 questions, right?
Yeah.
All at the same time. It's very unique, and that's when you know you're always onto something. Is when you have a brand new understanding of something, and then just because of that understanding, now you have the right question, and that's pretty awesome.
Well,
Not that it's super off subject, but I mean, did you want to show what you were doing with the couple of Tesla coils today, the Tesla coil and the Tesla coil, and maybe explain that a little bit? Because
oh, you want to see that?
yeah, I thought that was kind of interesting, and I think everybody out there would like to see it too.
Which one? Just the ones where I light them up with resonance, or the one where I did it on a short?
I mean, they were both pretty quick. Yeah, show them both.
Okay. Give me 1 second, and I'll pull it right up.
Maybe just like explain, what you were doing too, because frankly, like I understood exactly what was going on, but I didn't really understand why you were doing it. So maybe.
Okay, so just show this picture right here. Basically, I have a Tesla coil, and then inside I have a second Tesla coil, and then inside of that I have an aluminum pipe, and inside of that I have a what is that? Brass. It's a brass pipe, and they're all different sizes. They're all spaced out with tape so that you can't knock each other into the next one. I'm doing multiple field impingement, and I'm flipping fields in every one of these. So I go from a hot field on the outside to a second hot field on the inside because it's too close, to a very cold field in the very center of it. So when I do this, it creates the best resonance I've ever seen. It literally holds forever, and it pushes it out. So what I'm doing here is, I think on this one, I'm pushing out to a second Tesla coil that's just attached to the number 2 winding, and then we get plasma out of it. So I'll go ahead and play that. Right now, Tesla coil and 2 rods, all evenly spaced. But that's not the part that's going on right now. I got this hot side connected over to this Tesla coil right here. And I just want to see what kind of breakout I can get out of the top. And there's a weird phenomena going on. So let me turn it on. So there's no breakout, right? It's a lot of hot energy in there. It's running more like a flyback transformer. I'm working on a thruster right now. Okay, so it's a field flip, right?
Mm-hmm.
I made that outside extra hot by putting a core inside of an open core. I basically put a core down the center of it and made it come out just like a DC flyback. So it's interesting how it works, man. And that energy, by the way, it doesn't show up as like a it doesn't show up until you put the hammer next to it. And I tried a little razor blade on a stick, right? And I got these little tiny sparks, and I go, okay, I need more mass. So I just took my framing hammer, put it next to it, and then yeah. So it wanted that interaction with that iron. It drew out the energy. So when we go to field flip inside of a Tesla coil in order to get it to run a motor or something, now you know what we're doing. I need to create something that holds that current in there. I need the amps to pull in, you know what I mean, to a piece of iron. So, yeah. That one's
I'd ask you how hot it got, but it shorted out.
Oh, yeah. Be honest with you, most Tesla coils, they freak out when you do that, and they'll shut right off. Mm-hmm. And they won't even pull the energy like that. You'll see a real purpley spark, you know what I mean? Touch it.
Yep.
Not this one. You saw the white in there.
That wasn't cold energy, man. I've seen that kind before when I touched a 220 wire one time and lived.
Oh, yeah. You probably saw every star in the sky too.
I didn't. Yeah, that's a great story for another day. But yeah, that happened one time.
Oh man. So hold on. Let me go to this one right here. and I'll show this. This is me putting things in resonance. And I'll just play a little bit of it so you can see it. Those of you who haven't seen this before, I am literally running these coils with nothing attached to them. Here's my driving coil right here. I have my ZVS right there. And I have the cat bank Ian sent me. Awesome cat bank, Ian. These are all running on resonance. There is zero connected to them. They're just a number 2 coil on each one. You can see they're all lighting them up. I'm showing this again because I had somebody ask me about resonance and putting things in when you have an AC signal. And the AC is way worse than DC. So this frequency right here is where it has to resonate. Right there. It's got a little bit of fluctuation, but not much. Now, I want to show you how finicky this is. I'll take this light and bring it over here. There's a little cat bank, right? I'm going to set this up where you can see it. What about right there? So we can see the lights on. Now, I'm just going to flip one of these. As we flip them, now that just went dimmer. Now I lost the end one. There's my frequency. See, I went down just a little bit. Let's see if we can recover it. Okay, by the way, in Tesla coil land, that's a very minute number. In your frequency, what, 4 kilohertz? I mean, literally threw it right out, and you can see the lights are shutting off on me. That's how finicky these things are when you go to set them in there. And without that cat bank, man, you know how hard that is to try to adjust that wire and get the capacitance right and everything. It's super difficult. You see them changing. Okay, these are on. Nope, it does not like it. Resonance is like 2 ships in the night. They pass each other. So, let's go a little more. That was worse. That's better. Oh, that just killed it. You know, like clicking.
Kevin.
Here we go. We're back on. Back off. Back on. It's like wax on, wax off, huh? What are we doing? We're just switching this cat bank here. That's worse. There you go. Something. Okay, there we go. Now we got 2. Lights up real bright right there. Hold on. That means that we're just off by a little. Do you know what I'm off by right there? Okay, all the rest of them do not have a little tiny wire attached to them for the grounding. So when you slide it in your Tesla coil, it has like a 6-inch wire or something to it, right? The rest of them don't have that. This one does. That is the difference between resonance and non-resonance. Is that little tiny 6-inch wire attached to this stupid thing. And I didn't even think about it until I was done. And I said, there's got to be an in-between. So,
well, remember the higher off the ground you are too, like, the higher your energy potentials are. So, there's an aspect of it there too.
Oh yeah, a little bit of capacitance here. So we just need a little bit more. By the way, all these secondary coils have a Knowles point in the center. We're fluctuating right here. It needs to go down just a hair. I know the thing is we need to always try to hit a better value, but it's not about that. It's where it resonates at. So somebody say, well, it's a win. You're getting energy all the way over there at that one without anything attached, but it's not. You have to put it in resonance. Yeah. It's finicky. Sorry, I should fast forward it. Yeah, it's barely got any energy coming to this one. It lights up on the top because the wire isn't up there. So,
Also, lining them up straight one after the next like that is just like, as far as sequencing is concerned, that's like, not the efficient way to do it. If you were to stagger them and such, you'd be able to get more throw. But obviously that last that's a resonance problem.
okay, so it is literally bifilar at that point. Okay, it literally has a null zone, it has a top field, and it has a bottom field. The top field's resonating with it. The bottom field isn't.
Mm-hmm.
It's because of that stupid little wire. So,
yep.
Let me get you towards the end here. Oh, here we go. I'm going to pop this thing on here in just a few seconds. Dropped it again. Shut this down. There it is. And there it is. We got all of them lit now. We're in resonance. You see that right there? It didn't move much. But that's the difference between having it right and having it wrong. That's it. Now, is this the best for this main coil? So that's a big pain in the butt. You saw it barely moved, right?
Yeah.
But
that's frustrating, just being off that little bit.
Well, think about it though, but that's how the Earth works. So if you're not tuned into the exact frequency of the Earth, you're not going to get that massive number, are you? That's why it works that way. That's why people can't find things in resonance. It's not the one frequency, it's the two in oscillation together that creates that resonance that produces the energy. That's why they can go distances apart wirelessly, because they're creating energy inside the coil itself just by the resonance. You don't need the primary mover attached to it. You just need it to resonate the frequency. And so if you can think about that on like metal plates and stuff like that, if you can resonate the frequency of that metal plate, you automatically have way more power. So
yeah,
when I did that coil inside of a coil inside of a coil, that's Don Smith. That is literally Don Smith. That's building coils and getting resonances within each one to build energy so that it goes to an over unity number, because the frequency itself, when it's in resonance, gives you the energy.
Absolutely. I mean, that is now whenever you have the outward propagation of the energy that brings something else into resonance like that, it's that that transit and the picking up of the resonance of the new coil that's ultimately the manifest of the energy, not necessarily the direct output of the primary source. So you know, that's important. That's why distance plays a huge role in this too. You know, technically the further you could throw it, the more it could bring with it.
So I have another video. Let me see if I can't find it real quick. And it's a short video. When you spin that, not spin, but you get the resonance in your Tesla coil, and it's not letting me. Okay, there we go. Then you can get this thing to shoot plasma right out of it.
Mm.
So here we go. This one right here. Okay, let me rewind it. And God, I'm so old, rewind. There we go. You see it? Yeah. All right. So this plasma here, by the way, this coil, just like the other ones, there's nothing attached to it. Find the play button.
Look at that plasma swirl. That's absolutely beautiful. Well, that's the line that's supposed to go into the ground, too.
I was going to say, what's lighting up on the side?
Yeah.
Funny thing about this,
So it's bipolar.
Yeah.
is this secondary Tesla coil isn't attached to anything. It just resonates based on this one here.
Hmm.
So cool.
All right. That's enough of my Tesla coil tricks there. It's that resonance phase. You see how much plasma coming out of that? That's just pure energy potential right there.
Yeah, for certain.
That's why Don Smith's device works, because it resonates, gets the other ones to resonate, and they all have a different harmonic in it. He's literally building the ring in the coil, and as he does that, he gets pull off all the energy, and then he gets the other energy effect that when you have a coil over another coil, you get the magnetism that blows over, right? So your saturation on top of saturation on top of saturation. So he's taking advantage of everything he can.
Yeah, for sure. No,
And
makes sense.
then you run the wire right down the center of it in that same device, and you pick up more energy.
Well, then you could plug it right into a burrito and, you know, do whatever you got to do.
Field confinement, yes.
Yeah.
That Edwin Gray, field confinement of a scalar field in his gray tube is what produces all that energy.
Well, that's what that's what the gravity well is going to do too.
Yeah.
Field confinement, big time.
That's the reason we build them.
Yeah. How's that coming along, by the way?
It's going, man. I've been printing off parts all day.
Yeah, I get it. Been there, done that.
Well,
Not that, but I procrastinated.
So the motor works on it, right? And it spins it. But then I turn on my Tesla coil and it doesn't go back into this ball down there, right? But if you turn off the motor, it does. So what I found was because of the way the energy works with a hot draw, anything that's hot draws the energy to it. My motor's working as the hot draw.
Mm.
So it's literally pulling all of my Tesla coil energy out into my motor. And it's not killing the motor or anything like that. It's just
Kind of surprising.
Yeah, it's taking my energy away. So I had to make a coupler out of plastic instead of metal in order to get rid of that problem. It's the same thing I did in my gravity flyer, same thing. But I didn't even think about it when I built it. I'm all like, this looks good. I'll just order this little, $10 part. And yeah, sure enough, didn't use my brain doing that.
Yeah, well, but it's the same thing as that like little extra 6-inch piece of wire hanging off the end, But sometimes it just seems like it's all going to go right until like you look at it later and you're like, what's going on here? Why? Why is this being such a pain right now?
Dude, that green
But,
light would have lit up the first time if I just cut that wire. And I refuse to cut it because I hate soldering them on there.
yeah, well, earlier in the chat, I know Deadfish said that he thought we were going to have the UFO ready by this weekend, and he's kind of bummed out about that. So, give it a few more weeks, man. Like, hang in there. You've been here for like literally over 6 months,
Yeah.
waiting for it. You can wait a little longer.
Yeah, dude, that stuff takes time, man. There's a lot of good information that I just ran into on some of this stuff, man. It's changing everything. I didn't have the exact frequency for aluminum. Now I do. And I was building the capacitor and I kept sparking it over and blowing out the capacitor. So you get this big massive field in there, right? Then I push the button and it sparks and then boom, all gone. All computer goes. I'm like, oh my God, like an alarm, right? And I'm thinking, God, I just can't. And these things are so garbage, man. They're just like these wobbly discs, and it's like, man, could you just give me something that's solid that I could spin it perfect? I could just order the part. Nope, it'll be a wobbly disc.
Yeah, right. Getting things balanced when you're dealing with anything mechanical is a pain in the rear end to begin with. You know that if you ever got a big enough rock stuck in the tread of your tire, of the truck, or whatever, you'd be like, "What? Like, what's wrong with this thing?" Total clunker. It's like, oh wait, and you just pick it out, and it's like, oh, good to go.
Yeah, but dude, those discs have to be wobbly. Oh God, it's so stupid. Okay, you push the button, it pushes the capacitor and bends the disc up a little bit.
Yep.
And if it doesn't do that, you don't get the effect. Because the physics effect of this is real simple. Put two plates next to each other, right? You put in the energy, and then you pull them apart quickly. And it pulls the energy out of that center plate. Well, now imagine your Tesla coil being attached to that center plate. Now you have a field in there. You're about to flip that thing. So when we talk about field flipping, you pull it apart. It automatically takes the top disc, and it field flips it and pulls the thing in another direction. It's a wild thing, man, and it's hard to pull off.
Well, right. I mean, so the whole thing with that is rotational speed, right? Because that goes right along with resonance too. If you've ever taken something super dumb wobbly, where it'll like literally shake, like shake something apart, it's so bad. If you spin it and you keep on spinning it faster and faster and faster, you'll find that it ebbs and flows in terms of the felt vibrational frequency output. The closer you get to its sweet spot, and that goes in octaves also, right? So
yes,
then that's the whole thing. You could take the most fucking out of balance thing in the world, and if you could get it spinning at just that right, just that right exact RPM, it'd be like thing will be like slicing air.
Yeah.
Crazy.
So if you have the resonance frequency of the aluminum itself, right? Then you can calculate the ring of it and find out the exact RPM that each disc has to be at. Because the bottom one has magnets on it, so it's got to be a little bit slower. So it's going to be in a different part of the ring. Then you're going to hit at the top disc, the second part of the ring, right? The aluminum is the big one because it's the entire thing. That's your whole tree right there. That's how it's working.
Hey, listen, I hate to say it, but this is one of those situations where it's not that it's necessarily unachievable in a garage, but having like a 7 or 8 figure budget, and machine shops with like, all sorts of like lathes and metal, like fine tuning equipment and stuff, like that stuff pays dividends in the end. Like
it does.
Yeah, it pays dividends in the end, and then you have access to just more materials that have the attributes you need here and there, by different like exotic alloys and stuff. Like this is the difference, I guess. But it's part of the growing pain. You just try to overcome it.
Well, look,
and you try to be a little careful while you're doing it, because like 20 minutes ago, I think our new Russian friend in the chat put up there that he said you shake the ether the wrong way, Lucifer going to come up like Rainbow Lucifer out of the ether. Listen, I don't even
Yeah.
doubt that, man. I know the I know the spiritual journeys I've been on, bro, and like they've been real.
Yeah.
So yeah, you shake that ether, you get to see all sorts of fun stuff.
Oh yeah. Oh yeah. That's crazy, Joe. Things like
Yeah.
this just take time, man. And it's the small, like I showed you a testicle, the smallest little thing throws them out of resonance. Now, imagine this stupid thing shaking everywhere, and you're like, oh my God, dude, just smooth out for me one time. Just smooth out so that shake goes away so that I can get my grounding just right. You know what I mean? Then, boom, we can hit it. And drives me absolutely up the wall. I fiddled with this thing all day, and then, you know what I mean? I have to go on to another project and do that. And I have to wind Tesla coils tomorrow. So I told Charlie, see, I'd get him one at 1 megahertz, and I got to wind that tomorrow. And it's not that it's a lot of wire; it just takes a lot of time to get a cellular exciter to oscillate at 1 megahertz. So
Yeah. It's low.
yeah, well, 1 megahertz is pretty high compared to what we normally do. So that means the coil's like thin wire, maybe this big.
Oh, I didn't realize that's where it was running. Really?
Yeah, that's what he wanted.
Oh, okay. So you're pushing it.
It's not the frequency of the gravity flyer, but that's what he wanted. I think he has other experiments going on too. So yeah, it just takes time to calculate it and get it right. So it's what, 192.440, I think is what the number was for the frequency of aluminum. And then you can do the resonance on that and calculate the exact ring of everything, and then where your motors have to fly into it and everything else. And it tries to tell you every time you turn it on, right, where it is. By when you turn the motors, it starts to shake a lot more and start picking up more vibrational energy, right, just like that. And then when you start getting capacitance into it, man, it starts to really hum together. And you see the top and bottom motors go in sync. And then it's like, okay, we know we're here. We know, okay, we should have it now, right? Boom.
Yeah.
Blows it out and sparks over.
Yeah. Well, right. I think Brandon got us on that one, but Omni was saying, well, where'd the Scalar video go? Well, we finished it.
Yeah.
And it is all relative. I'm going to agree with Brandon there, because the whole entire idea is that the scalar vectoring is more the gateway to ether. Okay, so we need to be able to bring in those energies through the scalar vectoring to utilize in these types of systems to get the exotic phenomena, so to speak.
Mm-hmm.
To get the observable exotic phenomena, you need to be able to utilize that scalar vector. Something that is ignored, like they said in the video, glossed over. It becomes the uncomfortable conversation anytime it comes up in an equation. Because again, to give any sort of credence to the scalar vectoring, also gives immediate credence to ether, which is a problem.
Well,
So,
I mean, I just want to know what they're going to do. I mean, think about it. How many millions and billions of dollars has been spent in physics, and they don't understand this? Yet, I'm going to sit here in my garage and make anti-gravity before they even get close to it. Well, I should say that before the majority of them get close to it, because we already know Black Ops has it already. You know what I mean?
I was gonna say, you were getting right into that end of it. Like, it's not what they don't know. Like, I think one great example of that I saw recently, I think I shared it with you, was the Russians. Their Felon jet.
Okay.
Like the low speed
Oh, yeah.
maneuvering that thing does, is more than just thrust vectoring. I'm throwing that in there because, like, you could even watch the thrust vectoring in effect, and you could visually see that it's not enough to sit there and accommodate the dynamic of what's going on. Obviously there's control surfaces involved in that and so on. Like, it's a complex equation to get those types of low speed maneuvers going, but there's more in the works there too. It's a big aircraft. Like that's what it boils down to. And then, you look at the stuff that we've had and stuff that we've been doing, that's been right on par with that too. Maybe not in the low speed categories of it, so
Yeah.
much, or at least display wise. If our stuff does that, we haven't made it a point to show it in an air show, which is kind of the American way. Like we like things loud and fast,
Yeah. Well,
right?
tell you what, man, give me a proper lab, 6 months and, $1 million, and we'll have something off the ground in no time flat.
Yeah.
So, yeah, not all of us have that.
Yeah,
But,
well, the F-47 lib fucker is going to be a real piece of
oh,
work.
dude, that new jet. Oh my God, dude,
Yeah,
that thing was
that thing's going to
awesome.
be a piece of work. I hope Boeing comes through on that thing.
Yeah. Well, they probably already have, man. And again, we're probably 10 years behind everything.
Well, I mean, they admit that it's been flying successfully for 5 years.
Well, there you go.
Admit
They
successfully.
already had it.
Yeah, right. That's been going on for a minute and a day.
Yeah, man, that inertia gets broken down in any kind of time dilation field. And as soon as you start creating the field on the outside of this, by the way, there's only one way to do it. I'm just going to let you all know that right now. There's only one way to do it. And once you create that field, man, it's game over. It's almost like a jump drive. So if you start at this frequency here and you go to this frequency here, because time will stand still till you get from this point to this point, all you're doing is like Battlestar Galactica, man. You're putting in the jump coordinates and you are literally jumping from point to point. That's it. It's not hit the gas and get there. That's not the way it works. You're jumping through fields in the scalar, and that's the way it works.
Which is actually fantastic when you think about it, because not only does that mean that to the outside observer and to anything that really matters as far as the outside environment's concerned, are you doing the friggin' moonshine boogie and a half? But that means that as the person sitting in the cockpit, you have a huge sum of time to make critical decisions as that's going on. Like, get your head around that for a second. So, something like the 1 second outside perceived time, let's say it's even 5 seconds, for the pilot, right? Or 3 seconds for the pilot. Do you know what type of difference that is, when it comes to making a decision in a maneuver or something like that? Or, that's all the time in the world. That's what it takes to either get something done or not. Like, that extends your reaction time wildly to the point of where you could contemplate an action rather than having a reaction.
So let me ask you something. Do you think, along with getting rid of inertia, they're creating a different dimension where they're not interacting with the matter of the Earth itself or planes or anything else, that they literally just go straight through it?
I don't know. I think it's like, I think the way that it is, it's like it's at the cusp, right? So it's a manipulation or a modulation, but it's not fully on the other side where we would generally think about it as like time travel, right? So, anytime you're dealing with the Planck scale and you go on the other side of the Planck scale, either distance or time wise, right? There's this whole other entire circumstance that occurs. Okay. That's when you're dealing with the MH370 type stuff. Okay.
Oh, the plane.
All right. But the flip side of that, when you have a modulation of it that does not cross over, the Planck scale, now all of a sudden it just manipulates the perception of it. Yeah. So the outside observer and the inside operator are just they're just experiencing two different versions of the same reality subjectively, which is, again, get your head around that. It's objective in terms of what's actually happening, but in terms of the felt effects, it's all subjective. One person sees a jet blowing by like nobody's business. But meanwhile, the other guys, okay, yep, here we go. That's sort of it. It's crazy.
Yeah. Oh man. It'd be nice for them just to admit it and show it. That would be beautiful. But I don't think we're ready for it. To be honest with you, I think that's why they hold it back. Kind of got to get over the next, just parts of normal life and succeed to that next level and get everybody kind of on the same page. So,
yeah. Well, I think that if we're going to see it, it's going to be through, as I've said before, and I think that the more people that I hear speak about it, and Jarvis and what he's kind of saying, and like with the electrodes and everything like that, I think that there's fixed ways through solid states to be able to access etheric energy sources, right? And then be able to control their use so they don't go into the other realms of it that necessarily they would want to protect. So in the case of an electrode, I think that it would be reasonable to think that you could build up a static charge and then create motion to your static charge through a secondary source, right? To then make that energy from the static of the electrode that's indefinite rechargeable because it's working off of the etheric energy, to then be usable energy. And then that's what it's used for, usable energy. Does it have other effects? Yeah. But it also just is what it is. Right. So you really can't sit there and modulate it in a way necessarily that's going to create the density levels strong enough to sit there and be like, oh, look at this. Now, all of a sudden, the thing's floating off a table or the floor. Or, oh, look, there's a time dilation zone here where, some weird effects are going to occur or something like that. Like the major exotic components of it are kind of removed by virtue of it just being solid state and capable of whatever it's just simply capable of.
I was thinking maybe we should do, down the road, MH370 video.
Yeah, man. Yeah, that's been something that's always had my interest. I believe in that technology.
I mean, I'll look more into it to see what the actual physics and what they're doing on the plasmoids and stuff a little bit more. Because I'm pretty sure it has to do with microwaves and how they're putting the beam out there with the microwave in order to create the plasmoid in the atmosphere. Because lasers aren't going to do it; they're not strong enough.
I think that it's actually a compound system using microwaves and lasers, kind of having everything chase each other. Like in a package, so to speak, to create the high charges. Yeah. I mean, I know that's been like a hot topic on Ashton's channel for a long time. Is okay. We can understand how the spheres work, what they're doing, and how they culminate together to create what we can see in that video, right? But I think that the loaded question has always been, what is the mechanism of the cause of the orb formation? Is it something physical in there that we're just simply not seeing? I don't think so.
Well, hold on.
Personally, I don't think so.
Part of that video shows that the orb was pulled into the plane. So,
that's at the very end.
Well, no. I don't mean at the very end when you see the implosion. What I'm saying is the orb itself looked like it came from a different area.
Yep.
And was pulled in and then started rotating with the other ones. You know what I mean? And then pulled it back in. So there was a vortex forming behind that plane before this whole thing started. Before you started seeing them, there was a vortex forming in nature behind it. It had to. It pulled the orbs in from the atmosphere surrounding it. And then they started to vortex and go down the chute. That's what one of the footage I saw was.
I mean, this is just totally off the cuff, and I mean, I could be very wrong, but where my mind kind of connects the dots on this is when you look at like Bearden when he was talking about multi-vector scalar propagation interactions, right?
Yes.
So if you could create that large sum of energy remotely by vectoring an intersecting point of two scalar propagations, right? You have your density. Now, all you have to do is localize that. And I don't know how to do that. And if I did, I wouldn't go into that aspect of it. It's just not part of the conversation, right? You have your power density. Now you cut off the power density, and rather than having it return or redirect, it's just there, right? And now you can introduce a third, type of energy for it to potentially, follow the charge up. So if you have it charged one way, and then you shoot a laser, for instance, that has a different charge to it, there would be an attractive force. Now all of a sudden it could follow that path. Now once you have one, and then you get a second one to come into with that, now it starts acting like electrons do,
Okay, so
and starts doing the rotational thing. Now those fields of high density contained energy are doing the same thing that we're saying is being done in all these other scalar interactions, which is creating motion. That motion is creating higher density charges. And then once they reach a point of highest density charge, they converge and collapse. And that single point of extreme density charge is enough to create, etheric cavitation. And if the rotation of those around the plane are also creating an opposite charge around the plane by virtue of sucking in the other energy right around it, or jostling the other energy around it, now you have a situation where that convergence would take place and include the plane in that equation. I mean, I don't know that any of that's correct. I'm literally the community idiot.
I,
But it's, to me, that sounds good and explains that there's not some kind of like little steel ball in the middle of this creating some kind of effect.
yeah, I don't think it was that, man. It's okay. So the energy for the inside's already there. The static energy is already in the atmosphere at that level. Once you create the ring in the plane, then it creates a scalar potential. Now it has something to wrap that energy in. So now it can wrap it in an orb. That's why it's sucking into it. It's like somebody took the device for taking planes out of the air with pure resonance and causing turbulence to the plane and screwed it up. And when they screwed it up, it created orbs over there of pure energy as plasmoids, or ball lightning, if you want to call it that. And it takes both to make it. You have to have a radiant field holding in a static field. That's the way you make it. If you ring the plane, it's like ringing a Tesla coil. You literally have longitudinal waves. So that's why it's vortexing back towards it. So something in the tail end of that plane is what got hit, and it literally rung the whole thing and started causing the whole process. Somebody screwed up, is what it looks like. Somebody was trying to take it out of the air, and they hit it with the wrong frequency. The frequency itself started to hit the same ring as the energy around it in the scalar field. And then guess what? Now you got plasmoids. Now you got a massive energy potential in a plasmoid, and you just screwed that plane. They take them out of the sky with resonance. All they do is create turbulence. So if I just told you the frequency of aluminum, then literally all we got to do is resonate the aluminum, and they fall right out of the sky.
Yeah, 100%. I mean, it'd be majorly problematic.
Yeah.
That goes right back to Tesla when he, accidentally shook New York, but didn't feel a thing.
No. Which makes you wonder, was he in a time dilation field right there and didn't realize, or did it come back on him and didn't shake his building?
The resonance of his building, right, was like at the sweet spot where everything is nice and like still, technically, by vibrating the beam of the building and in the proper resonance, you could create any sort of sway or fluctuation in the building whatsoever to disappear entirely at the right resonance. The problem is that if you're hooked up to bedrock, and the bedrock starts shaking at a different type of frequency, and then you have other buildings and ground and such at the area that is at Schumann's resonance specifically, let's just say, all of a sudden those are way out of resonance, and that's a vibratory effect, a severe vibratory effect when you're out, right?
I don't think he hit that frequency dead on. I think he hit the outside of it. I mean, if he hit it dead on, man, he'd be in a big chasm, big hole. You know what I mean? That earth would have opened up and swallowed him.
Could well be. I don't know. It's one of those interesting things that, like, honestly, my understanding of the device that he used to just create that vibratory oscillation was that it was nothing complicated. Like, imagine taking your fucking Xbox controller and just vice gripping it, like a beam in your house, and being like, all right, let's cook this baby until we get the result. Like, I couldn't imagine it being much different than that.
It wasn't that. It was the low frequency oscillation, and then he pulsed it with the water hammer and steam hammer on the bottom part of it. People don't see that. They don't understand. There's an amplification going on there that's pushing it out. It's like creating a sound wave and pushing it all over the place in order to hit everything in the whole room. You know what I mean?
Yeah.
So he pushed his resonance across the table. It would be the same thing as taking a tuning fork and putting it in the box and letting it shoot across the room. It's the same effect.
Right. And then that boils back down to like beat frequencies and stuff like that he was probably creating as a result of that too, which is just like a whole nother layer of the issue. But good old Tesla.
Good old Tesla.
Good old Tesla. Yo, I'd have been such good friends with that dude. I've been like,
oh yeah,
this sounds like a terrible idea. He'd be like, it's fine. I've thought about this.
oh man.
Yeah. And then he'd ask me for money, and I'd be like, bro, how many times do I have to tell you I'm broke? But Joe, if only I had $100,000 more dollars, I'd be like, yeah, bro, if I only had another $100,000 too. What year is it?
Yeah. Dude, I'll tell you what, this day and age, man, he'd have every job in the world, man. He'd get all kinds of billions because now they want it.
He might even be able to be employed by his own company.
Yeah. That's so sad.
Could you imagine, man? Would he have to apply?
He's got an interview with HR. He's literally smarter than you, looking at you like, dude, seriously?
Boy, oh boy, oh boy. No, I think he'd be extremely fascinated by seeing, what total bastardizations of his technology we've come up with. He'd be like, wait, you've come this far and this is all it does?
That's all it does. You tell everybody they're wrong. Just tell everybody they're wrong. That's bad.
Yeah, he was a proud dude, man. He had no problem whatsoever going toe to toe with people, like, and being like, why are you doing it this way? This is wrong. Like, no problem whatsoever.
You travel to them by train or whatever, and then go over there and tell them they're wrong, and then travel home. It was literally a different day and age, man.
I don't know. His whole like social pattern, the more you like find out about him and stuff, and just how he was and what his interactions were like, and like some of like the naivety or whatever, and everything with him, like you realize like chances of him being like deeply autistic were like high. Like
it's almost like he had Asperger's, man.
Yeah, he had something going on, man. I don't know. Yeah, and I'm not knocking people that have that stuff, like, like it is what it is.
Not at all.
It could be your blessing, could be your curse. I don't really know, but I think Tesla definitely like.
I think some of that, dude, is like a blessing. People don't see it that way.
Well, right. This is exactly what I'm saying. I mean, some of the autistic people I know, man, like they're brilliant people. No social skills, like that is what it is. But like,
that's okay.
It's fine. Like my social skills are limited too.
I'm telling you, man, my wife has ADD, so talking to her is like talking to 5 different people, man, which is kind of bad for me, but she worked in sales. So answer one phone, answer another phone, talk to this person over here, and keep all the conversation straight. You got me, man. You beat me. I can't do it.
Oh, I have terrible ADD, bro. It's like not like the good hyperactive kind where like you just like blazing guns of glory all the time either. Like I just sit there and I'm like, what am I doing? Huh? Like all the time. And then sometimes I have moments of brilliance and I'm like, wait a second, what was that?
Yeah.
Yeah.
Oh, man.
Unfortunately for me, that came out as an adult though. Like I didn't have that when I was a kid.
Really?
Yeah. Right? It's crazy. Uh-huh.
All right. You know what? Give me a second. I was going to look something up. I didn't know if I had it here. Now, oh, maybe I did. I made a new graphic. I just wanted to see what everybody thought about it, man. So here we go.
Yeah,
Ready, Joe?
Yep. Uh-oh, we just blew up the woomometer.
Oh, man. If you got emojis for the channel, man, throw them up. We got some woo going on here.
Throw them up. Throw them up.
Yeah. Some woo. Some what the W2F in there, and then emojis passing wind. Heck yeah, man. Get your membership now. You have some fun.
Damn right. And plastic 3 holes is still there. Yeah, that one's there forever, man. Like there'll never be a moment as good as the 3 holes.
Oh my god, dude!
You know, we have a lot of new viewers that might want to see 3 holes.
Yeah, we could.
I think we got a lot of new viewers that want to see 3 holes.
Okay, one thing first. We're gonna play the short version of us. I should have played in the beginning. So give me a second here. All right, guys. This is Joe. It should have been the intro right here. Sorry for that.
Oh, we're dropping the intro.
In a world across the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world, the universe is all fuel. It takes the talent of the craftsman, it takes the mind of the fool to make the vision realize energy and matter in a duel. To a break, to a duel. The old man Bill was running through his head. Cheryl probably got it hiding under his bed. Penny up for any, making power for days. Don't listen to a word that the straight no says. Might building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Sean chucking plasma volts a mile long. Sheila on the video making tone jump strong. Burning, breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the dope big old man Bills.
All right, I'm looking right now, guys, for the three holes, man.
Yeah, it's been at least 3 months, at least, since I've seen that, and that's overdue.
Oh, okay. Huh. Episode 1, man. Oh yeah.
All right, for those of you who haven't seen this, it's painful. It's painful.
Dude, it's just the funniest thing in the world.
It's so funny.
This is the captain speaking. Have you and Ben been able to fix the transporter yet?
That's what I'm saying. I can explain to you very simply how to verify if that ground, the third prong at the bottom, the circle hole. I think it's 3 prongs, right? 3 holes. You're in Canada? I don't know.
No. It's 3 holes. Yeah, it should be.
So you have the ground. The third hole is the ground. So you could test that ground by. You have the 2 other holes. Are they the same size or is one bigger?
I'm sorry. Say that again.
You have 3 holes. One is ground at the bottom, and the 2 that are at the top are the power. Are they the 2 holes? Are they the same size, or is one bigger?
No. They're the same size.
Same size. So it's two. You're in Canada?
No, I'm in Michigan.
Michigan. So it can't be the same size. One slit is a little shorter.
Are you sure? Let me see.
Look closely.
Look
You need more light in
closely.
there.
Oh yeah, you're right.
I'm sorry, Mike. Did you say you had the transporter fixed?
Put the voltmeter on AC 120 volt setting. Put one prong in the ground and the other prong in the smaller hole. That's your hot line. And if you get 120 volts, that ground is working good. If you don't, you get less than 120 volts, like 90 or 80, your ground is probably no good on that plug. That could cause a lot of issues for the circuit too, by the way.
Well, the problem is this only goes up to 10 amps and then it blows.
No,
so-
you don't need amps. You just need 120 volts is what it should read.
Okay. As long as it doesn't blow my fuse.
Put it
I'm
on
good.
volts, not amps, volts. 120 AC volts.
This should be this should be good to 250 volts. So we should be okay.
Hey, Gerald, come here and listen to this. I can't tell if they're fixing the transporter or not.
Right. So now put one prong in the ground, the other prong in the smaller hole, not the bigger one, the smaller.
Does it matter which one is which?
You know,
Right.
it kind of does matter. But anyway,
Yeah, it matters.
Wait, so the red
of the two holes, other than the ground hole, of the two holes that you have there, one is smaller. That is the smaller hole is the power. The bigger hole is the return for that power.
the negative. Okay.
Yeah, you
So-
don't want to use that to.
All
check
right,
your
so
ground. You wanna
real
check
quick
the
before I
power.
electrocute myself, Mike, which
You're not
which
going to.
hole do I stick this in?
Don't stick the plug out. Just stick the prong.
hole is red, they're so wrong.
The probe has two prongs, two metal.
I'm sorry.
Put
This
one
one got
prong in
really
the ground and the other prong in the smaller of the two holes that are left.
but it doesn't matter which one is which.
No, it does. One of the probes, you have two probes from the voltmeter. One goes, no, it doesn't matter which one of the two goes in the ground. No, it doesn't.
Okay, so I can put the black one in the ground and then
Yeah.
the red one in the
Yeah.
small slot.
Yes. Sorry, I
Okay.
misunderstood you there.
No, it's okay. We're talking about putting things in holes.
Yeah, easy to get confused.
Mike prefers a certain one.
He still didn't get it.
So yeah, if you don't see a 120 volts right away, just wiggle it around till you get a good connection. You
Wiggle
can
it.
either 120 volts or like less than that, like maybe 100 volts.
easy.
Bit on it.
Yeah, 120.
Okay, your ground is good. You just verified it. It's good ground.
Nice.
Now, just so you know, if it read less than 120, like around 100 or 90 or 80, that ground is no good.
Oh,
Right. Okay. It was actually slightly above 120. So is that normal?
Yeah, you're
It's
good,
like
you're
120.
The ground is good. Good.
Awesome.
Just make sure you're firmly connected to that third prong into your circuit.
Something tells me we're never getting this transporter fixed.
If you were to put one prong into ground and the other prong into the return, you wouldn't get anything because it's not sourced. You're not hitting source. You want to go from ground
oh
to
my
from
God.
source to ground together.
Oh,
No, that makes sense. If it's
Oh.
not properly grounded, you're going to be getting a loss.
You're right, Nathan?
yeah. I'm living right now. I'm barely breathing. Oh, man.
Thanks, my cheeks hurt.
Oh, Mike's best segment ever. I
Oh my
swear.
God. That legitimately went on for like 5 minutes explaining an outlet.
Oh, yeah.
Like, bro, you about to play with high voltage? You're worried about an outlet.
The worst. Ben was on all fours, bent over, looking at the outlet, and all you saw was his ass on the screen. Oh,
I wasn't
man.
sure if he was trying to fix whatever it was down there, or if Leonardbot was standing up.
Oh, no.
I wasn't sure.
Oh.
Balls. Anyway, I'm going to hell.
Oh, man, Joe, that's too good. All right. Let me ask you something, Joe. Do you want to see the mushroom one real quick before?
Yeah, we might as well. It's Friday night, boys. Bring on the shrooms.
All right, here we go.
Do do
Give me a second.
do 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 do
Ground,
do.
Okay.
bottom.
There we go.
This is your captain speaking.
Okay.
Joe, can you please report to the transporter room? We need to go back to the planet where you found your strange rock. Bernie's going to meet us down there. Mike, transport us down.
You have three holes. One is ground, and the two that are at the top are the power. Are the two holes, are they the same size? Or is
Oh,
put one prong in the ground and the other prong in the smaller hole? That's your hotline.
still talking
Is he
about holes.
daydreaming again? Hey, Mike, transport us down to the surface, please. Okay, Joe,
Oh.
where exactly did you find this strange rock?
And I could sense it. So like I'm very attuned to it. I could like sense it as soon as I like start fumbling around with it. I'm like, up there it is, you know.
Well, let's keep moving down the river to the cave where Bernie is. Oh, man, look at all these magic mushrooms.
All right.
Joe, have you ever eaten any of these things?
Psychologically, having high amounts of that crap around wasn't the best for me. You know, like would always kind of grab me, and I'm like, oh yeah, all right, that. You know, and this kind of did that, and it was very, very, and it wasn't bad.
Well, after careful consideration, I say we eat some of this stuff and see what happens.
Wow. Instant brain fart there.
Are we still in the cave?
Oh,
Why is
man.
everything moving? What's going on, guys?
Direct departure. You know, the 90% of the brainwashed, most senior epic legends and pillars.
What the hell did he just say? Oh my God, I'm tripping balls, man.
I'm deep into meditation, you know, and different spiritual aspects and stuff like that of metaphysics,
Oh,
and I could tell you, I mean, these things they do have psychological effect, as far as that stuff goes. And
My lips aren't moving, but I'm still talking. Must be an inner monologue. Awesome. We want to turn it on. We want those effects. We want our mind, the machine. You know what I mean?
Mhm.
So we can figure out how exactly to do it.
Spinning, the rotation aspect, that is now one dynamic of open system adding to it.
So it's like, oh, well, I mean, what's the difference? It's like, because things don't do this.
Yeah, that's why.
That's why. You see, like, yeah, it's subtle. You're running your finger across something and you're feeling it starting to skip on the surface, but it's smooth.
oh.
It's like things don't do this, and this does this. And yes, it's subtle, but it's there. But then there's the more extreme examples. Like the thing. Taking a lift off, and it's like it just slipped out of your hand.
Oh my God. I can hear Joe in my head and Bernie in my head, but their lips aren't moving.
And then
Which
it's like, so you
isn't
add that
at all. You
spinning
push it this way, it
to
goes that
other
way. You push it this way,
aspects,
it
like
goes that
bringing
way,
in
and
radiant
then the thing
energy
isn't going to
from the
exert
environment,
its
like
own
if it's
force
endothermic
out
cooling
of my
or
hand
from a
that you
plasma,
can
right? All
feel
these
on your
other
hand.
aspects, you start
like,
combining
we're
those
supposed to be
dynamics
doing
of extra energy
Burst
in
down
that
like a
you're
sack of
able to
potatoes
get the
to the ground.
exponential
Sack of
gains
potatoes.
and I
in
couldn't
your
move.
systems.
You have three holes. You have three holes.
have three
You have
holes.
three holes. You have three holes. You have three holes.
Oh my God. There's no more holes. There's no more holes. There's no more holes. Mike, beam us up.
Boss.
You're right.
Oh, yeah. I'm living right now. I'm barely breathing. Oh, man. Good times, brother.
Classic, Red. Classic.
Oh, dude, you gotta have a good laugh at the end of the day, man. Those are absolutely hilarious.
Oh yeah, definitely. Although I'll tell you what's really good
What's it?
I found one of those AIs that do like those deep fakes.
Yeah.
And like you could do like Elon Musk ones for free. You could be it's really funny.
Oh,
And it's like an actual video of him like saying what you type into and it sounds just like him. I'm like, yo, this is pretty legit.
that's cool, man.
Yeah. That'll be next level version of that.
It's already bad enough, man. Like the guys not moving or anything, they're just standing there, but it's a story. It's like I took everything
so
completely out of context.
Yeah. Oh man. We did so many good things with that. Like when I blew Leonardbot's weenie off. Sean had to fix it. Sean always comes through. Listen.
let me
Good
tell
man,
you,
smart, capable. He fixed my mistake.
the more straightforward you are and like the less, you know what I mean, you're goofy, it's the best, dude, because it's like it makes it so much funnier. Oh.
Good times.
Oh yeah. So how about that scalar physics, man?
Just like that.
Just
Any
like
questions?
that.
Could have been the whole episode. Oh wait, hold on. That too.
Oh man, it's fun. All right, good night tonight, man. This is awesome.
Nah, man, no better way to spend a Friday. Nathan and I are working out the schedules and everything like that. You know what day we're gonna have our cast. So tomorrow, you know, it will not be me. So yeah, well, we're gonna figure that out. Whether it's gonna continue on Fridays or do Mondays, whatever works best for the show. What you guys dig, you know, I'm there for it. But you know, I think that having Saturdays freed up a little bit is going to be nice. So
Yeah. Well, enjoy them, man. It's just fun to do the show with you, man. So Friday,
no,
Mondays,
I love it, and I would trust me if it was Saturday or nothing, it'd be Saturday all day, every day. That's that.
Right on, man. We'll figure it out. It's all good.
Yeah.
I'll get the right intro this time.
Hey, listen, I love your intro, man. I can't even.
Yeah, it went turned out
Can't
good.
even
But
talk
see,
about that.
let me tell you what, us animated, like talking and moving our hands like all over the place was like the best.
Yeah, no, it's great. Just goes to show what a good time we try to have with this. We're talking about freaking physics.
Yeah.
You know, like talking about most of the time. I mean, other times we talk about other shit, but like most of the time we're talking about physics. How entertaining can you possibly make that? We try to make it as fun as we possibly can, given it's like, you know, if you took it in school, you probably skip class, you know? Just trying to get people not to skip class.
Yeah. Well, put out some good information, man, for the first hour and a half, and then all bets are off, man, because you got to have a little fun.
Yeah, that's it. Yeah.
All right, Joe. I'm about done, man. How about you?
I think this was amazing. I loved it, every minute of it. And you know, we'll definitely take into consideration too. One thing I wanted to kind of bring up was, you know, if the chat has any topics that you want to see us cover, you know, specifically, leave it in the comments after the chat's over. You know, so after the stream is over, go back to the comments, just leave a comment, what you want to see, and you know, we'll definitely take it into deep consideration, because we could talk about the same stuff over and over again 100 different ways, but I want to make sure that everybody's you know, what they want to see, that's being taken into the fold too. And for anybody else out there that you know, has either something they want to talk about or show, you get in touch with me or Nathan. We set that up too. As you know, we try to make this as open a forum as possible to our viewers to come on and share what you're doing. So we'd love to have you.
Yeah, if you got an experiment to share, or you just want to talk some physics or something, by all means, come on. We'll talk. You know what I mean? I may be a more of an engineer than a physicist, but if that's what you want to talk about, we're happy to have you. And
Well, at least you're that, because I'm just an idiot. Hey guys.
No, it's even open to everybody, man. Everybody gets their say. So yeah, if you want to get on the join and have some fun and talk and laugh a little bit, we're gonna have to make you giggle though. So that's it. That's just part of the territory. So
That's it. It's
all right, guys.
little unsafe, safe place on the web.
It's the funnest place, I'll tell you that. All right, guys, with that said, I want to thank everybody in the chat, man. You guys have been totally awesome. Thanks, Joe, for hanging out with me and doing this, man.
Always.
Have a great night, guys.
Peace and love. Don't forget to roll the credits.
Battling the establishment for just a little recognition. The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time. Battling the establishment for just a little recognition has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time. Battling the establishment for just a little recognition has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time. Battling the establishment for just a little recognition has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.